My name's Gizmo, and I'm a pig. I've discovered an amazing fact about circles, and I want to tell you about it with the help of my inimitable sidekick, Poob. Poob, draw me a circle. Very good, Poob. Poob! That's better. Now, the thing that I've discovered is a way to calculate the area of a circle. Poob, get rid of that! It doesn't even look like a proper letter. Now, Poob, I don't want any more messing about. Let me do the talking. The formula I'm talking about involves the circumference and the radius of the circle. Now, the circumference is the distance all the way around the edge, which you could measure with a little trundle wheel if you had one, trundling around the edge until you got back to where you started. And I'd write that as C. And the radius is the distance from the centre to the edge, and I'm going to write that as R. Now, the formula for the area is a half C times R. So you take the circumference and the radius, you times them together, and you divide that by 2. So where does this formula come from?
Excuse me.
What is it? Who are you?
I'm Barry.
We're trying to make a video here, Barry.
I know. But I'm confused. I thought that the area of a circle was pi r squared.
What are you talking about, man? Pies?
No, pi the number. It's like 3.14 something. And the circumference is 2 pi r anyway. So pi r squared's the same as half CR.
So Barry, what you're saying is you've got a different formula that's equivalent to this one.
I suppose so.
But worse, because you can't even remember what this stupid number is. Well, thanks for your contribution, Barry, but I think I'll stick with this one. Now, where does it come from? Let's divide our circle up into equal slices, as if it was a cake that we were cutting up. Oh, Poob, sorry, I know you're very hungry, but we're nearly done. Now, each of these slices is really a triangle with a little curved bit added on. A bit like a cone with a bit of ice cream sticking. Oh, sorry, Poob. Sorry. Now, the more slices we use, the more of the circle gets filled up with triangles and the less with ice cream. Oh, sorry. If we just take the areas of the triangles, we get closer and closer to the area of the circle. So what's the area of a triangle? Well, let's take one of these little triangular segments out, and then let's turn it on its side. And here's what the formula is. So the bottom of the triangle is called the base, which I've coloured in blue. And the vertical height of the triangle is called the height, which I'm colouring in red. And the area of the triangle is a half times the base times the height. So you times the base and the height and you divide by 2. Now where does this come from? Well, if you colour in one half of the triangle grey and then flip it over to make a rectangle, then you can see that rectangle is, it's got one side, the red side, equal to the height, and the other side is half the base, so that's what the area of that rectangle is. It's the same as the area of the triangle, because we didn't change the area. Now, as our slices get thinner and thinner, the height, which is the length of these little red lines, gets closer and closer to the radius of the circle, and the base of the triangle gets closer and closer to the length of a little segment of the circle. So that means that the area of each triangle, which is a half the base times the height, gets closer and closer to a half the length of the segment times the radius. So when we add them all up, the area gets closer to a half the circumference times the radius, which is what I said it would be in the first place. Now I think this formula is great. Exactly the same formula can be used to find the area of a cone. It's a half CR, where C is the circumference of the circle at the bottom of the cone, and R is the height along the edge of the cone. Imagine if you were walking up a pyramid with a trundle wheel, trundling up. It would be the... what's that, Poob? You'd fall off. Yes, you probably would. But if you didn't, you'd measure this number R. And exactly the same argument tells you that the area of that cone, not including the bottom bit, just the slanted bit, is a half CR. And it doesn't involve any mysterious pies. Tune in next time for more about pseudo-holomorphic curves, and we'll talk to this rabbit about his life in mathematics.
Do I get a mention?
What are you still doing here, Barry?